Morning guys, we're going to go over just standard error today, so it should go pretty quickly. So standard error, first of all, we're using our equation right there. So when we look at it, we're finding the sum of our y minus our y predicted values squared. Okay, we're going to find the sum of all of those ones. So what we're going to go ahead and do is, from yesterday, we came up with our slope and y-intercept. So we had our slope and y-intercept, which gave us our predicted y value. And then our residuals was just the difference between our actual y value and our predicted y values. And so we got this. So now what we're going to do here is we're going to take it, we're going to square these values, and then we're going to take the sum of those. So that's what you're going to see me do now, is I'm just going to come through here and square these values. So I'm going to hit equals. I click on my residual, 1.96, and I square it. Raise it to the second power. That's like a little caret button on number 6. On the number 6, that's how you square something. Okay, so we square it, equals this to the second power. Okay, why isn't it showing up? There we go. So we square it. We'll do for all of those. So we square all those values, and then we just equals, and then find the sum of that. So now we find the sum and put it there. So this is the sum of all our residuals squared. So if you really think about it, this is just the sum of all your residuals. So now what we're going to do is going to take this value, we're going to plug it in here. We're going to hit equals, the square root, SQRT. And then we're going to go n minus 2, which is our sample size. Again, in this case, our sample size was 8. Okay, so we're going to go equals this value right here, the square root of this value, divided by 8 minus 2, which is 6. So I'm just going to plug in 6. So the standard error, so I'm going to come down here. The standard error is equal to the square root, so SQRT, square root of this value, the sum of all those residuals squared, divided by our sample size, 8 minus 2, which is 6. And that would be the standard error from it. So that's what we're looking for as we go through it, when we go through it. So again, if we're looking at kind of the standard error, what are we trying to find with the standard error? We're trying to find what is that average distance between the actual value and our predicted value. And so the smaller that our standard error is, the more accurate our line is as we go through it. So I just wanted to show you that's what you're going to be doing. Same thing, then we're just finding the standard error today.